talked about two different ways to graph a line, either using a table of values or being able to go and use our x and y intercept. Well, could I use a table of values? Absolutely yes. But again, it's kind of cumbersome. Could I use my x and y intercept? Well, if I want to estimate the graph, the answer is yes. Because what would be the y-intercept of that line? What would be the y-intercept of that line? -2, 0, -2, right? Okay. But what would the x-intercept of that line be? Yeah, 4/3, 0. Now, could I estimate where 4/3 is? Absolutely. 4/3 is 1 1/3. But my graph is not calibrated in thirds, it's calibrated in whole numbers. So if I want an accurate graph, I need 2 whole number points. Well, that brings me to the third way to graph a line, and that is using slope-intercept. Slope-intercept. Okay. Slope-intercept form for the equation of a line is y equals mx plus b, where m is the slope and b is the y coordinate of the y-intercept. Okay, so m is going to be your slope, and b is going to be the y-coordinate of your y-intercept. Now here's how this works. Step number 1, and one of the reasons why we did what we did in chapter 1.6, especially with literal equations, is we've got to be able to go ahead and change forms. This particular equation right now is in standard form. 3x minus 2y is equal to 4. The first thing we need to do is we need to put it into slope-intercept form. Well, slope-intercept form, we need to solve for y. So I end up with -2y is equal to -3x plus 4. I have to subtract 3x from both sides, get it over the other side. Last thing I need to do is divide by the coefficient of the variable, which is -2. We're going to divide both of these terms by -2. So y is going to be equal to 3/2 x minus 2. There is my equation in slope-intercept form. These are exactly the same equations. One is in standard form, one is in slope-intercept form. The next thing we want to do is we want to identify the components of what we have. Well, the slope of this line is 3/2. The y-intercept of this line is 0, -2. We now have everything that we need in order to be able to graph that line. Now I want to talk a little bit about slope. Okay, slope. First of all, slope is nothing more than the steepness of a line. That's all that it is. Mathematically, it's change in y over change in x, or if you remember from high school, it's rise over run. It's rise over run. The top number is the number of units you're going to move up and down on the y-axis. The bottom number, the denominator, is the number of units you're going to move back and forth on the x-axis. Now, something I want to talk about just from an arithmetic perspective. 3/2. 3/2. 3/2 is either +3 over +2, or it can be -3 over -2. Both of those are positive 3/2 because a negative divided by a negative is also positive. Okay, it's also positive. And the reason I bring that up is so when we use this particular slope, we can go in either direction. When you're going to use slope-intercept in order to graph a line, the biggest mistake that's made, for some reason, people start at the origin. You don't start at the origin. The very first thing you do is you put on your given point. The given point here is 0, -2. There is my y-intercept. That is where this graph must cross the y-axis. I'm going to use this slope as +3 over +2, which means from here I'm going to go up 1, 2, 3, and write 1, 2. and I have another point, and that's all the points that I need in order to graph this line. I'm going to go ahead and connect these points. And I'm going to talk about slope a little bit more here. But there you go. There is the graph. There is the graph of 3x minus 2y is equal to 4. You can put more than 2 points on there. You can get more points just by using your slope. From here, I could go up 1, 2, 3, and write 1, 2. That's another point that would be there. 1, 2, 3, and write 1, 2. That point would be on the graph. Also, you can go in the opposite direction. That's why I did this. Negative 3 over negative 2. You could start here and go down 1, 2, 3, and left 1, 2, and you'd have a point right there on your particular graph. So once you have your slope and a point to start with, then you're ready to go ahead and graph that line. That's how you use slope intercept. But the first thing you need to